Hello students, in this video we'll see how to solve problem 5.2.107. Problem 5.2.107 asks us to solve the initial value problem, y double prime minus y prime minus 12y equals 0, with the initial conditions that y of 0 is equal to 0 and y prime of 0 is equal to 14. So to solve this, we write down our characteristic equation. Our characteristic equation is r squared minus r minus 12 equals 0, which we can factor. We can write this as r minus 4 times r plus 3 equals 0. So our roots of the characteristic equation are r equals 4 or r equals negative 3. And from this we write down our general solution. Our general solution is y equals c1 e to the 4x plus c2 e to the negative 3x. Now we'll plug in our initial conditions. So we know that y of 0 is equal to 0. And we'll need to compute the derivative to compute the derivative initial condition. So my y prime will be equal to 4c1 e to the 4x minus 3c2 e to the negative 3x. So now if we plug in 0 to this, we have 0 is equal to c1 e to the 0 is 1 plus c2 e to the 0 is again 1. That's from my y of 0 equation. And from my y prime of 0 equation, what will we see? We'll see that 14 is equal to 4c1 minus 3c2. So from this problem, we have two equations and two unknowns. So if we take this first equation and we multiply it by 3, we will have 0 is equal to 3c1 plus 3c2. And if I take this equation, which we just found, and add it to the second equation, so adding these two equations together, we will have 14, 0 plus 14, is equal to 7c1, and then the c2 terms will cancel by construction, which tells me that c1 is equal to 2. If c1 is equal to 2, this top equation tells me that c2 has to be equal to negative 2. So I found that c1 is 2 and c2 is negative 2, so we can now write down the solution to our problem. The solution to our problem is y is equal to 2 e to the 4x, that's my c1, and then minus 2 e to the negative 3x. So we use the characteristic equation to find the solution of the homogeneous problem, and then we take the derivative of that so that I can plug in 0 into both the derivative and the original function to find the constants c1 and c2. Thank you very much.